Hi, I'm Mike and this is my Lab 1 constant velocity. So the purpose of this lab is to observe an object at the same speed without changing direction, so an object in constant velocity. The models I'll be using is free body diagrams, glow script, and tracker. Physics principles I'll be using is Newton's first law, Newton's second law, and kinematic equations. Preview the results is the object will continue to stay in motion at a constant velocity since there are no forces acting on the object. So this is a video of the object in constant velocity, and this is the same video in tracker. Systems and my assumptions. The system is the ball, and the surroundings is the floor and air. The normal force is equal to the gravitational force, so the F net will be 0 in the y-axis. There is a little bit of friction in the x-axis, but it's negligible, so the ideal system or the predicted position graph is going to have 0 for that. The ball is in a constant velocity, and due to Newton's second law, since the ball is at a constant velocity, there are no forces acting the ball. F equals ma, since acceleration is 0, force is going to equal 0. Due to Newton's first law, the ball will continue to move at a constant velocity if no outside forces act on the ball. So this ball is going to continue at its constant velocity since there are no forces acting on the system. The initial conditions is that F net is equal to 0. The ball center of mass starts at the origin, as shown by the picture, and the initial velocity is 1.363 meters per second in the x direction. So these are my calculations. For the initial velocity, I took the change in distance for the first time interval over the change in time for the first time interval, and that gave me 1.363 meters per second, and then that's what I plugged into the kinematic equation for distance, and that would give you any distance at any time interval. The observed position is using tracker, you plotting every point, the center of mass over each frame in time. We'll plot your position versus time graph, and that's what tracker did. The glow script basically took the initial position and did and then plotted each position over the time interval by adding the velocity times the time interval to give you a constant velocity and a linear position graph for position versus time. This is the it basically used the first kinematic equation, the distance one, to calculate the position versus time graph. The observed versus prediction position comparison. The observed position velocity is gradually decreased because in that system, again, there is a little bit of force friction, although negligible, it still acts on the object, while the predicted position velocity is constant, so it's a little bit higher at the end. Its displacement is 0.046 meters further than the observed position at 0.77 seconds from the origin. So that just shows that in our predicted positions velocity, there was no force friction. It was a constant velocity and it got a higher value, which was to be expected. The conclusion is that even though there was a force friction reducing the velocity of the observed position graph because perfect conditions are never possible, the lab demonstrated using Newton's first and second laws you can predict the position of an object at constant velocity relatively accurately. Any possible errors is the plotting the points on tracker. I may not have been exact since it was done by hand. Therefore, the initial velocity might have been affected and any subsequent points. What if and what does it mean? What if the x axis was negative? What if they were flipped? Your initial velocity would have been negative and the graphs would have been the same except reflected across the x-axis. Is it possible to say how many forces are added together to give 0 net force in the case of the observed? No, because the free body diagram has the force of friction acting on the object. For the actual system, it would have not given you a 0 net force in the x direction. But but it would have predicted because we assumed that force friction was 0. Thank you.